So let's say that we have this digital logic circuit and we want to turn it into some structural Verilog. So let's get into it. The first thing we need to do is kind of define our module. So we're going to have module and then a name. Let's just call it example. And then we just need to have our list of inputs and outputs. They can be in really any order. I'm going to just do kind of A, B, C, out. Don't necessarily need the spaces in between there, but it can just make things look a little bit more readable. And then just right now, before I forget, I'm going to put an end module in there. No spaces, just end module. So these are kind of acting as our brackets to encapsulate our module. This is the start of the module, and of course this is the end. Now, we need to declare our inputs and outputs for this module. So in this case we have input and we have A, B, C, and that's it. And if I wanted to be really proper, I could add some comments in here and say list all the inputs. And our output is just out, semicolon, list the output. And I could also, just to make it formatted a little bit better, I could space that over and maybe space it so these comments are lined up, just to make things a little bit more readable. And now I can get into my structural specification. Actually, I can't. The reason why I can't just quite get into it is I have one last thing that I need to define, and that is my wires, right? So I've declared my inputs over here, right, A, B, and C, and my outputs, but there's also these intermediate signals, right? Here's one, here's one, here's one, and here's one. So let's declare those, and if possible, let's try and give them meaningful names. So like when I say that, these inverters, I can give their outputs meaningful names. And unfortunately, I don't have my drawing tablet, so this is going to be a little blocky, but I've got A, we'll just say AN, a little lowercase n, how about? AN, and we got CN, and then we'll just call this guy X and this guy Y. So these are our intermediate wires. Let's make a list of those. Wire, and then we'll space over, and we've got AN, CN, X, Y. And these are our immediate vars. Don't quite have enough space, but that's okay. And we'll just keep everything looking fancy if we can. All right, now we can actually get into our structural specification here. And so since all these operations happen at the same time, the order that we make these doesn't super matter. So I'm just going to do my nots first, just to get those out of the way. So we've got not, and so our output is always listed first. So that means we got AN, and then our input is A. So that's the wiring for this NOT gate right there. Let's make another one. So we're outputting to CN, and our input is C. All right, that takes care of all of our NOTs. Let's do the big AND gate. So we've got AND. Our output is going to X, and our inputs are A, B, and C. Now let's do that OR gate. So that OR gate, its inputs are actually all wires. They're all from intermediate variables. So not that that means anything. I'm just kind of pointing it out for your recognition. So we're outputting to Y, and our inputs are X, and C not. And our final gate is the exclusive OR gate. And our inputs, or first our output is just out. And our inputs are A not and Y. And so that's just about it. Well, not just about. That is how we'd go about defining this module using just structural specification.